Okay, so those changes that I talked about won't be uniform. Even in the best case scenario, there's going to be a lot of warming in the Arctic, whereas near the equator, not so much. So that warming will not be uniformly distributed around the globe. This is one of the reasons why it's important to keep in mind that when we talk about global warming, it's important to make sure that we are thinking about that critically, because not everywhere in the world is going to warm at the same rate. And in fact, some places might not even warm. Future changes in temperature are not uniformly distributed. Land is expected to warm more than oceans do. One of the reasons why this happens is because land heats up faster than oceans do. Oceans absorb the same amount of heat as land, but they don't warm as quickly as land does. Don't believe me? Take a pot of ice water, turn a burner on, take something like a piece of soil, turn a burner on. That soil will heat up much quicker than that water will heat up. Another good example, go to the beach on a bright sunny day, put your feet in the sand, sand's hot. Walk out to the ocean, ocean's cold. So the land is going to heat up more than the ocean does. And then Arctic regions, specifically the North Pole, are more likely to warm than other latitudes. And the reason why is because those Arctic regions are made up of ice that's barely below freezing. Just a little bit of warming is going to cause all of that ice to melt, and boom, it's going to get a lot warmer very quickly because all of that ice melts. That lowers the albedo, that leads to more warming. Sea ice extent will continue to decline. In the RCP 2.6 scenario, it continues to decline until about 2050, then it kind of levels off. In the RCP 8.5 scenario, by the time we get to 2100, and in many predictions even before that, minimum summertime sea ice may be completely gone. So pretty much see you later, ice. Santa Claus is going to get an eviction notice and the landlord is climate change. Not fun. And yeah, that will lead to more warming. Why? Because more warming means more ice melt. More ice melt means lower albedo. Lower albedo means more warming. And that process is just going to keep happening. That process is just going to keep happening. All right, last thing I'll talk about before I get into impacts and consequences. Precipitation. Contrary to popular belief, the world is not going to become some gigantic desert. Believe it or not, a warmer world will be a wetter world. Let me say that again. A warmer world will be a wetter world. But when I say warmer will be wetter, I don't mean for everybody. There will be winners and there will be losers. Areas in the North Pole in particular, they're going to see the bulk of the warming. They're going to see a lot more evaporation. They're going to see a lot more rainfall, a lot more precipitation. Equatorial regions, believe it or not, are also expected to see a lot more precipitation. However, the mid-latitudes, roughly straddling 30 degrees north and 30 degrees south, are expected to see more drought and desertification. So the reason why this happens is global warming changes Earth's weather patterns. That's why we call it climate change instead of global warming, because the warming of our Earth actually causes weather patterns to change, and those weather patterns dictate other elements of climate, such as rainfall, such as temperature even. So just to end this part of the module, now talking about the models and then the predictions. A model is a simplification of a complex system. Climate models break the Earth up into small grid boxes and then calculate a prediction for each one of them. We verify climate models by comparing what has happened to what the model says happened. we've found that we can actually predict this somewhat reasonably well. There's still room for improvement, and we're continuing to improve. The models are getting better and better and better and better. Interestingly enough, though, the picture is becoming dimmer and dimmer and dimmer and dimmer. We cannot perfectly predict human activity, so we need to develop emission scenarios. And really, the results are, if we don't get our act together, we're pretty SOL. Why are we SOL? I will talk about that in the next video.